Hi guys, welcome back. We are looking at our acid-base ionization lab today. We'll start with the review just like we normally do. So let's go in and see what we're trying to review today. For each acid or base, tell me if it's strong or weak, what type of acid it is, Arrhenius, Bronsted, Lowry, or Lewis. If you're given a 0.1 molar of each species, do you know the concentration of each ion? If so, what is it? Okay, so I've got myself a table. I've got a molecule, strong, weak. I know what the conjugate is. I don't know if it's an H plus or OH minus donor. I want to know, does it fit Arrhenius, Bronsted, Lowry, and Lewis? Okay, awesome. And if it's a 0.1 molar solution and I'm generating H plus or OH minus, I'm going to put that concentration in the H plus or OH minus column. Okay, so let's talk about HF. HF is the first one we want to talk about. Come on. HCl, H2SO4, HNO3, MgOH2, BaH2, NaOH, and finally NH3. Okay, let's talk about HF, strong, weak acid. Well, it's on the strong acid list, and it turns out that HF is an exception. It's the only halogen acid that is not a strong acid, and that's because there's a very high affinity for that F minus to the H. Okay, so this is a weak acid. Its conjugate is the F minus, so we've taken that proton off of it. We have the F minus. But I don't know what that concentration is going to be because it doesn't come apart 100%. So I don't know what that concentration is. I don't have any way to calculate it at this point. Do I know if it's an Arrhenius acid? Does it donate a proton? Yes, it does. So it qualifies. Oh, sorry. Didn't give myself a lot of room for that one. So, get rid of that line. Get rid of that line. Sorry. Can't draw straight. Okay. A little better. A little bit. So, does it donate a proton? Yes, it does. So, Arrhenius, yes. Does it donate a proton for Bronsted Lowry? Yes, it does. So, it's a Bronsted Lowry. Does it accept a pair of electrons? No. F minus does not have any space with which to do so. So, there is nothing that's going to go in the Lewis box. That's what I'm going to fill in for that. HCl, strong or weak? Strong. Okay, awesome. Conjugate, once I take that H plus off, I get a Cl minus. Concentration is based on what I put in there, so 0.1 molar. Does it donate a proton? Yes, it does. That makes both of those, right? Does it accept a pair of electrons? No. Chlorine, again, is completely full. It's a halogen, so we can't do that. Right, so that is where we're done with that. Now, H2SO4. H2SO4 is in the list of, let me verify, sorry, I'm pulling test handouts so that I can look at that. I'm pretty sure it's on that list, but I just need to verify. I open up to my strong acid base table, and I do see sulfuric acid in that list. Okay, so sulfuric acid is a strong acid. Okay, awesome. Its conjugate is H SO4 minus. And the strength that I'm going to put is 0.1 molar. It donates that proton, it donates a proton, and it does not accept a pair of electrons. Okay, so again, that's where we are. Now, does that H from the HSO4 minus come off? Yes. Do I know how much? No. So I'm not going to talk about it right now. Okay. HNO3 is also in my list of strong acids. So it's strong. Its conjugate is the NO3 minus. So we've lost that proton. That means that this one is also 0.1 molar. It donates a proton. It donates a proton. Yes. Awesome. MgOH2. Well, MgOH2 is not in my list of strong bases. Okay, fine. So that makes it a weak base. Do I know how much of it I have? Not at this point. No, I don't. Do I know what its conjugate is? Yeah, the part that's left other than the OH is the Mg2+. That's the conjugate that I'd be talking about. I don't know what its concentration is. Does it donate an OH minus? Yes, it does. Can it react with an H+? Can it accept that H+? Yes, it can. Can that OH accept or donate a lone pair? It can. Okay, so oxygen has 3 lone pairs on it. It has the ability to donate those. So it can act as a Lewis base. Okay. Now, when we talk about BaOH2, that's in my list of strong bases. Okay. The conjugate of that is the Ba2+, so it's that metal. How many OHs do I get for every BaOH2 I have? 2. So its concentration is going to be 0.2 molar. It is a base. It does donate an OH minus. Can it accept a proton? Yes, it can. Can it donate that pair of electrons? You bet it can. Okay, so there, we're looking at that again. NaOH is in my list of strong bases. Its conjugate is the Na+, so the metal that's left. Concentration is going to be 0.1 molar, because there's only 0.1. There's one Na for every one of those. It donates an OH minus, it accepts NH+, and it can donate the O lone pairs. NH3. NH3 is not in the list. That makes it a weak base. Do I know what its conjugate is? Yes. When it picks up a proton, it becomes NH4 positive. Okay? Do I know what its concentration is? No, I don't, because it's weak. Is it an Arrhenius base? Did it donate an OH minus? No, it did not. Is it a Bronsted-Lowry base? Can it accept a proton? Yes, it can. Is a Lewis base? Absolutely it is, because it can donate that and the nitrogen's lone pair. So yes, that is true. Okay, now like I said that you would see one of these. There you go. All right. Here's that. Okay, so that's my table. Now let's go to the second one. Review 2 says given 0.025 molar BaOH2. What is the concentration of B? I'm actually going to move it down here so I can do each calculation. BaOH2, concentration of H plus, concentration of OH minus, the pH, the POH. Okay, so let's look at BaOH2. And we talked about this a couple of minutes ago. That was a strong base, so it completely dissociates. If it completely dissociates, then there will be no BaOH2 left. Okay, all of that is going to become OH minus, and that OH minus is therefore going to be 0.25 molar. If I want to calculate the H plus, I take 1 times 10 to the minus 14th. I divide it by that OH minus concentration, and that will give me the value that I need for the OH, or for the H plus. And that gives me 4 times 10 to the minus 13th. Now, I have an OH minus of negative or of 0.025. So I can take the negative log of 0.025 to give me a pOH of 1.60. My pH is then 14 minus that value, and that gives me 1.24. Now, this number right here is also 10 to the negative 1.24. Okay? So that's what we're looking for there. And we know that's not the right number. My calculator's still in scientific notation, so I made a mistake. This is 12.3 and a 40 because it rounds up. 40. 2 sig figs after the decimal point is 40. And then this is 10 to the negative 12.40. So, and of course, how did I know that I'd made a mistake? Because it didn't pass the smell test. If I was putting 10 to the negative 1.24, that concentration would be way higher than what it is. So that didn't pass. So I had to go back and calculate it again. Go awesome. All right, so that's 2. Anything else? No. We're not going to talk about anything else at this point. So that covers almost everything that we talked about last time. Now, what are we going to talk about today? Well, we'll talk about that in just a second. We'll put this review as its own bit, and then I will come back and talk about what we're going to talk about today. All right. Thanks, guys. See you soon.